Our research project is called Influence of Microclimate on Particulate Matter Distribution in Santiago, Chile, which is a collaborative work between two schools in Santiago, Villa María Academy, represented by Dominga Gracia, and Liceo Carmela Silva Donoso, represented by Catalina Varas. Our research is related to air pollution. It is important to mention some general concepts. First, that air pollution can be caused by natural phenomena or by various human activities. The most important emissions are carbon monoxide, nitrogen oxide, sulfur oxide, ozone, and especially particulate matter type PM10 and PM2.5. The particulate matter as a pollutant highly dangerous for all health due to their very small size, which can be seen in the figure, where the diameter of hair has been compared with the particulate matter. This figure allows it to be breathed by humans, reaching the pulmonary alveoli where the exchange of hazardous chemical occurs. During the month of June 2015, the city of Santiago, Chile had a very poor air quality. A local newspaper showed the increased pollution observed for 13 consecutive days. The authorities declared an environmental alert, trying to reduce the emission of pollutants in the city.
This image shows a spring or summer day with low pollution. Warm and less dense air tends to rise, which generates movement and dispersion of pollutants. By the other hand, in winter time, at low temperatures, we can see the effect of the phenomenon of thermal inversion. The air above the Earth's surface is more cold and denser than the middle layer. It produces the inhibition of the vertical movements of air, allowing the formation of layers of heavily polluted air, causing the effect of pod lid over the city. Based on Opaso's work, there is evidence that temperature variations between the eastern and western areas of Santiago can promote a significantly different distribution of particulate matter PM10. In the image, it is observed that the difference of temperature caused by the wind blow provokes that the particulate matter accumulates predominantly in the western area. A heat urban island can be seen in the image. The city temperatures are higher than rural areas. One of the causes of this phenomenon is the amount of buildings, which are built with materials that absorb and accumulate heat, so it can be dissipated easily. The lack of green areas and excessive use of cars can contribute to develop heat islands.
Question is, do exist significant difference of local temperature between these both schools that could influence the distribution of particulate matter PM10 in the air? Our research hypothesis corresponds to the different distribution of PM10 in the región metropolitana is influenced by the distinct temperature found in the city of Santiago, Chile. Our overall objectives correspond to study minimum and maximum daily temperature in the period from May to June in both schools, Villa María Academy and Liceo Carmela Silva Donoso, to identify a potential effects over the distribution of particulate matter PM10. The specific objectives are 1. To measure minimum and maximum daily temperatures in VMA and LCSD. 2. To analyze the temperature data recorded by graphical representations. 3. To compare the temperature profile to the pollution data of PM10 registered in two of the MACA monitoring stations, Las Condes and Parque O'Higgins, close to VMA and LCSD correspondingly.
In this picture, we show both stations. Upper image corresponds to LCSD and the lower to VMA. The methodology used was: first, the research site was set up as described in the Globe Protocol. The instrument's shelter was placed and the thermometers were calibrated following the protocols. The minimum and maximum temperatures were recorded every 6 days using the digital dual sensor thermometer. All the measures were performed after the solar noon. The maximum and minimum temperatures were analyzed and the thermal amplitudes were calculated. The data for PM10 emissions were obtained from Parque O'Higgins and Las Condes Macam stations. Finally, the relation of PM10 and the temperature profile for each school was determined. These are the results of our research. This graphic shows that temperatures are higher in LCSD than in VMA. The average difference between both schools are 3.2 Celsius degrees, and it remains constant during all the studied period. This graphics shows that temperatures are lower in LCSD. The average difference between both schools is 1.1 Celsius degrees. It remains constant in all the studied period. This graphic shows that the thermal amplitude in LCSD every day are higher during all the study period. The average difference between both schools are 4.3 Celsius degrees that remain constant in all the period except between May 7th and 15th.
Table 1. Monthly summary for the thermal parameters obtained in both schools. Each value corresponds to the average temperature registered during May and June. It is emphasizing that the LCSD corresponds to a heat island compared to the VMA, according to the means obtained.
The last figure shows the emission of particulate matter PM10 registered at both stations for the studied period. The concentration of PM10 and therefore atmospheric pollution is higher at Parque O'Higgins station. Also, during 11 days, it was higher than the primary air quality standard that corresponds to 150 micrograms per cubic meters. In contrast, Las Condes station did not exceed the primary air quality standard throughout the study period.
So, our hypothesis was accepted. Our work concluded that there is a correlation between the temperature measured and the atmospheric particles pollution as detected at east and the west location in metropolitan Santiago during the period.
With these results, our future plan is record hourly variation of the temperature along the day and characterize urban conditions of VMA and LCSD sampling sites. Inquire on distribution and sources of atmospheric pollutants, mainly PM10, particulate matter, during extreme pollution events in Santiago. Inquire of quality of life conditions for workers, students, and general population as affected by air pollution increase. Diffusion of basic scientific research procedures and pollution sources and effects at both school communities. This work have an impact in different aspects, social and political, public health and environmental among others. However, the impact on the education is the most important for us, because the students can develop several abilities such as critical and creative thinking, effective communication, technological abilities and the sense of social responsibilities. Also, the collaborative work between teachers and students from different schools, private and public institutions from the district is a good model for social integration.
Finally, we appreciate the support for the development of our research, the U.S. Embassy in Santiago, Ministry of Education of Chile, University of Talca, Para Explora RM Sur Oriente. Thank you very much.